Now let's continue on chapter 5, which is biofuel. In this chapter, we're going to cover subchapter number 1, which is palm oil methyl ester as diesel substitutes. Subchapter number 2, which is fuel properties and biodiesel standards. Subchapter number 3, quality control of palm diesel. And subchapter 4, methods for analysis of blends of palm methyl ester and petroleum diesel. So in this chapter, students should be able to evaluate and explain the processing techniques for oleochemicals, derivatives, and biofuel. Okay, what is biofuel? Okay, so we know that in this country, we have produced biodiesel. Okay, so what's the use of this biodiesel? Okay, so the production of biodiesel is actually depends on the demand that has been created few back years ago. Okay, so the use of the number of vehicles in this world keep on increasing. Okay, so the demand for petroleum also keep increasing. Okay, and then the issue is that petroleum stock is not sustainable, all right? So it might be last for few decades. Okay, so the demands of fuel keep on increasing even though the stock for the crude petroleum is no longer exists in this world. Okay, so therefore, okay, we can see that more research has been done on biodiesel production because this biodiesel is considered as promising biofuel in the future. Okay, and we know that we have learned about the production of biodiesel before, and we know that biodiesel, they are produced or derived from vegetable oil. Okay, and because it is derived from vegetable oil like palm oil, okay, it is the most promising alternative for the fuel in the future. Biofuel, or you can call it as a liquid fuel, can be derived from other materials too. Okay, and examples of biofuel produced from other materials can comes from waste plant or maybe animal matter. Okay, so one of the example that we can have here is oxygenated organic compounds from cellulosic biomass. Okay, so the biomass that you get from the cellulose, like the leaves or the pulp or the corn waste that you can generated to produce ethanol or bioethanol. Okay, and others include biomethanol. Okay, so these undergo a complicated process. Okay, and then one of the example is the pyrolysis oils, or maybe you can have Fischer-Tropsch fuels. There are many advantages that you can get from biodiesel. Okay, so when you talk about biodiesel, it can be used in existing engine, okay, without any modification of the oil, right? And then the second one is that it is made entirely from vegetable sources. So therefore, it does not contain sulfur, aromatic hydrocarbons, or metals, or maybe crude oil residues. Okay, so the third advantages that you can get is that it is an oxygenated fuel. Okay, so when you talk about oxygenated fuel, the emission of carbon monoxide and the soot tend to be reduced or minimized. Okay, And then biodiesel also do not contribute to global warming. Okay, and OSHA classify biodiesel as non-flammable liquid. Okay, and the use of biodiesel can be extended the life of diesel engine. Okay, because it is studied that biodiesel, when you use biodiesel, okay, it will produce more lubricating characteristic. Therefore, it will protect the engine. Okay, when it's compared to petroleum diesel fuel. Okay, and then it is being produced from renewable vegetable oil. So the word renewable is very important here. Okay, thus improve the fuel of the energy security and economy independent. Okay, even though you have many advantages on the biodiesel, there are some disadvantages that you can get from biodiesel. Okay, so biodiesel produce lower energy content. Okay, and it's also poor in the cold weather performance. Okay, so the study has been done based on this. Okay, so the biodiesel tends to freeze or become solidified at the cold weather. Okay, so because of this, okay, the stability of biodiesel cause a great concern to the uh, the people who wants to use biodiesel. Okay, and then when you talk about biodiesel, if it is going to replace petroleum diesel or petroleum, okay, we have to think about the scalability of biodiesel production. Okay, so currently the feedstock technology are very limited. So the production of biodiesel is very limited. Okay, so we cannot produce yet the abundant production of biodiesel. Okay, so that's why the scalability become the great concern, and the stability of the properties of the biodiesel also give a great concern to the people who wants to use biodiesel. So here we can see the progress or the implementation milestone of Malaysia biodiesel research. Okay, so actually it's starting from 1981 to 1984, where the Malaysian Palm Oil Board began first pilot palm biodiesel plant project. Okay, and then when you talk about this, okay, in 2007, the implementation of the Malaysia Biofuel Industry Act 2007 for the licensing of the blending mandate. So you can see the gap, okay, when MPOB was first set up the pilot plant of biodiesel, it takes more years, quite a long time before the act of implementation of Malaysia biofuels are introduced. Okay, and then followed by after 3 to 4 years. Okay, then you can see the launch of B5 blend. Okay, so what is B5? So when you talk about B5 blend, it represents 5% palm biodiesel will be added to 95% petrodiesel. Okay, so this is the quality that we have for B5 blend. Okay, now after 3 years or 3 to 4 years, then we have Malaysia has launched the B7 blend, which is 7% palm biodiesel and 93% petrodiesel. All right, so still you can see here that the quantity of biodiesel added or to replace a diesel is only in a small quantity, 5% to 7%. But in 2018, we can see the increment where they launch the B10 blend. Okay, at this time, the blend of the fuel is 10% from biodiesel and 90% from petroleum diesel. Okay, and in 2020, okay, there is some improvement again based on the research. Okay, uh, it is scheduled that B20 blend, okay, will be introduced. Okay, so in this case, we can see that the increment from 5% in 2011 to 2020, you can see the progress in the development how biodiesel can be replaced can replace the diesel fuel. Okay, where we can have a blend of 20% biodiesel to be added to 80% of petrol diesel. Okay, so these are the improvements that we can see previously. Okay, we do hope that when the times come, okay, maybe we can use 100% of biodiesel to replace the diesel fuel. Now let's look on the palm oil methyl ester as diesel substitutes. Okay, so previously we described how biodiesel can substitute a certain percentage to the use of diesel fuel. Okay, now let's focus on the biodiesel made from palm oil. Okay, and this biodiesel made from palm oil is called palm oil methyl ester. So let me clarify here. Okay, so biodiesel is not just a raw vegetable oil or what you can say as a crude vegetable oil. Okay, so biodiesel must be produced. Okay, must be produced by a chemical process. Okay, so there are many processes involved. Okay, to come up with the production of biodiesel. One of the chemical process involved is called trans-esterification process, or maybe you heard about the other process which come from the esterification process. Okay, so you can read on that particular process, but what we are going to focus in this topic is how biodiesel is used, is going to be processed and then to replace the biofuel or petroleum fuel. Okay, like what I have mentioned before, okay, the production of biodiesel must come from the chemical process. So one of the chemical process method used is trans-esterification. Okay, and you can also have other types of chemical process which is called microemulsions, and you can have thermal cracking, and you might want to have maybe direct use and blending. Okay, so what I'm going to explain here is about the most famous process that has been used in the industry, which is called trans-esterification process. Okay, so I think you have done this in your chemical engineering plant design. So you choose the process of trans-esterification. Okay, and we're going to have a reaction between triglyceride and alcohol. Okay, so you can have alcohol, whether you can have methyl or ethyl or propyl. Okay, but in the process between the triglyceride with the alcohol, the process is quite slow. So therefore, we need to have catalyst to be present in the reaction. Okay, so when we have a reaction of triglyceride with alcohol and with the presence of catalyst, so we got to have a control on the temperature, okay, temperature or the reaction temperature in the process, okay. So when we have a control on the temperature or maybe the reaction time, okay, we might get a good result, okay. So the products that you're going to get in the transesterification process is called methyl ester and glycerin, okay. So this methyl ester is called the crude biodiesel, okay. So we have to know that why we use catalyst, okay. Definitely catalyst will increase the rate of reaction, okay. And then why do we need to control the temperature? This temperature is called the optimum temperature, okay. So it has been studied that the optimum temperature used in the transesterification process is between 60 degrees to 70 degrees Celsius, okay. And you have to mix the alcohol and triglyceride with the vigorous agitation so that you can have a good surface area contact between the triglyceride and the alcohol, okay. And the types of catalysts that you can use is the alkali based catalyst such as KOH or NaOH, okay. So the most popular types of catalysts used in this process to produce methyl ester is homogeneous catalyst, okay. Even though it produce soapy product, okay, but this is the cheapest process, okay, in the industry. So this one shows you the chemical reactions involved, and you can see that the reaction is a reversible reaction. Even though you use catalyst to increase the rate of reaction, still the reaction is reversible reaction. So in order for you to make sure that you get the methyl ester and glycerin as your end product, not to have the reverse product, which is you're going to get again your glyceride with the methanol, but at this time the raw materials is not in the good condition anymore, okay, because it has been undergo the chemical reaction. So therefore, to avoid messy production, okay, what you can do is to promote the reaction to go forward, okay, to promote the reaction to go forward. So in this case, we need to introduce or we can apply excess reactant, okay, excess reactant. So you know how much triglyceride that you want to use, therefore you just increase the amount of methanol. So methanol is considered as your excess reactant to make sure that you have forward reaction, okay. If you look at this equation, all right, this chemical equation, you have 1 mole of triglyceride react with 3 mole of methanol to give you 3 mole of methyl ester and glycerin, okay. So in order to promote the reaction to go forward, what you need to do is to increase the amount of methanol. For let's say you're going to use 6 mole of methanol, okay. So when you use 6 mole of methanol, okay, you can force the reaction to go forward, okay. But definitely you have make sure that all the fats, all the triglyceride has been reacted to convert into methyl ester and glycerin, okay. Towards the end of the product, you're going to have extra methanol to be recovered. Because methanol is easy to be recovered, then it's okay to have methanol as the excess reactant. Okay, now looks at this particular process flow diagram. Okay, so the process flow diagram in this process flow diagram, you can have, you're going to use trans-esterification process. Okay, so in this trans-esterification process, you're going to react methanol with the triglyceride. Okay, triglyceride, and then maybe you want to use sodium methylate as a catalyst. Okay, so in this reaction, okay, you can get fatty acid methyl ester and glycerol. All right, so to separate this fatty acid methyl ester, before this you can just get these two mix in one particular mixture. Okay, so you need to separate fatty acid methyl ester from the glycerol. Okay, so how do you separate this? Okay, for the trans-esterification process, you're going to use a reactor system to produce your product. Okay, once the product has been produced, now you have to separate fatty acid methyl ester from the glycerol. Okay, so in this process, okay, based on your plant design project, you're going to use a system which is a byproduct removal system, just to separate fatty acid methyl ester and glycerol. Remember that when you want to separate these two, you can separate the glycerol because glycerol is heavier, okay, and you still need to further process your fatty acid methyl ester. So you're going to send your crude fatty acid methyl ester to the washing system, okay, to the washing system. All right, so in the washing system, you're going to use about hot water. Okay, the temperature of the water is about 65 to 75 degrees Celsius, and you're going to mix with the fatty acid methyl ester in the washing system. Okay, so you're going to wash your fatty acid methyl ester until you get your pH nearly neutralized. Okay, until pH 7 or 6.5. Okay, so we need to wash fatty acid methyl ester because when we produce fatty acid methyl ester in the trans-esterification process, the fatty acid methyl ester is very acidic. So we need to wash that with the water. Okay, then you need to settle, to give some times, okay, to settle the water and the fatty acid methyl ester in the tank. Okay, so you can observe that fatty acid methyl ester will be the mixture that you have will form two layers. Okay, the top layer will be your oil and top layer oil, yeah, and the bottom layer will be your water. So you're going to separate water and leave the fatty acid methyl ester behind. Once the pH of this fatty acid methyl ester become almost 7. Okay, the next step is you need to dry the fatty acid methyl ester because previously you wash with the water, so you're going to have water in your oil. Okay, therefore you need to dry your product. Okay, so in the plant design that you have, you're going to dry it using a vacuum dryer. Okay, so at this position, you can get rid of the water or the moisture content that you can observe that you get from the product of washing. Okay, so once you can you dry the fatty acid methyl ester, now no more water that you can observe from the product that you have. So the last product that you're going to get is called biodiesel. Okay, so remember in the trans-esterification process, there are a few parameters that you need to consider. The reaction temperature must be between 65 to 75 degrees Celsius because this is the good practice that you get from the industry. Okay, so this is the range of temperature for the reaction that can give you optimum production. Okay, and then you have to make sure that you introduce a catalyst to increase the rate of reaction, and then at the same time you're going to introduce excess reactant, where your excess reactant is your alcohol. Okay,